So what we have is a review packet for the volume chapter. Um, so we'll go through these problems and try to keep it under 10 minutes. So this first problem, even though that's the first one, it's really a tough one to start with. A lot of steps in it, and we'll have to really persevere here. So you're designing a box to hold 24 of their spherical ornaments. So right now, just kind of take note of what we're reading. Okay, each sphere, each ornament has a radius of 1.75 inches. Okay, that's going to get us. We're going to need the diameter, and you'll see why in a minute. So that's going to give us 3.5 inches for the diameter. Let's see. So the 24 have to fit in this, in this box design here, and they're suggesting we go 2 layers of 4 by 3. So basically, here's what that means. Okay. So if you're looking at it top-down view, you're going to try to go 4 this way and 3 this way. And we can repeat. That's what we're essentially looking at. Now the side view, you're going to have 2 layers of that. Also, we have to put an inch of packaging between any ornaments. So and the side of the box. So here's a 1/2 inch of packaging. There's going to have to be a 1/2 inch here, 1/2 inch here, and so on. And then a 1/2 inch at the edge. So you got all these 1/2 inches this way. Okay. You're also going to have that going this way. I forgot this one too. And so there's 4 of those that way. Okay, so basically what we're looking at is the dimensions of the box are basically what we're going to be looking for. Dimensions are length, width, and height. Okay, so now let's call the 4 ornaments going this way the length. Now, we have to go the full diameter, right, for each of them. So the radius of 1.75 doesn't do us any good. We need the diameter. So we got 4 diameters. We're going to start with the length. We're going to have 4 of the diameters, which are each 3.5 inches. Okay? And we're going to have packaging. We've got to see that there's 5 kind of rows or columns of packaging, all a 1/2 inch thick. You can put the 1/2 or the 0.5, whatever. So when we do that, it looks like the length is going to be 16.5. Okay, we'll continue. We know that, of course, choice 4 is going to be our answer, but we should make sure. The width of this. So we're going to have pretty similar. We're going to have 3 diameters, right? 3 diameters, 3.5s, and only 4 layers of packaging. Now that's going to round out to 12.5. Now for the height, okay, think of it up and down. You're going to have 2 spheres, right? 2 layers. That's what that 2 layers is. So you're going to have 2 spheres stacked. So 2 of those diameters. Okay, and then there's going to be 3 layers. 1 layer packaging under, 1 between, and 1 on top. Okay, that's going to come out to 8.5. So yes, this was the right choice. Okay, inches, that's the symbol for inches, in case you didn't know that. So that takes care of the first one. That is actually, I made it look easy, but that's very tricky to go through. So, all right, the second one, all right, another one that's, we're not going to be easy here. So a soda company looking into different options for a 40-ounce cola can. All right, some of it got cut off. They found that anything larger than a 3-inch diameter is good. Okay, so they're going to assume we use a 3-inch diameter. Now we're looking for the height. All right, we assume that everybody knows a soda can is a cylinder. Okay, so one of the first things I have my students do is identify the shape, choose the formula for volume in this case, um, from the formula sheet. Don't try to memorize it. Just go ahead and, get that formula. If you have a diameter of 3, we're looking at a radius of 1.5. Now let's fill in everything that we can fill in. Well, let's do a calculation first. Okay, 40 ounces is not a good volume for us. What we need is cubic inches so that we can convert, or have to convert, and then we can solve for the height. So let's go with this. So if I want to fit 40 ounces, I need to solve for how many, I'll call it x, cubic inches. Now, what they're telling me is this conversion right here. This is the key to the whole problem. 1 ounce of soda is proportional to 1.8 ounces of, or 1.8 cubic inches of space. So this is how I do it, is proportions. We've talked about that in previous videos. There's many other ways to do it, but this is how I do it. So we'll get the cross products or cross multiply, however your teacher teaches you that, and then 40 times 1.8. So our number of cubic inches ends up being, where did that go? 72. So we get 72 cubic inches of space for 40 ounces. So that's what we're going to use for our volume. Okay, so volume gets replaced by 72, 1.5 squared, and we're going to solve for h. So I'm just going to condense this a little bit. It's 2.25 h. Sorry, so 2.25 pi, because I just squared 1.5. 2.25 pi h. Now, be careful when we divide. Your calculator, if you're using that Inspire, and you use the big fraction symbol, that's what we do. If you don't have the TI Inspire, if you have a TI 84 or whatever, you got to make sure that you're careful about what you're dividing by. Divide by 2.25 pi in parentheses. Now the big fraction, that takes care of that in our Inspire. So when we go ahead and do that, we get about 10.185. All right, if you can't seem to get your calculator to do that, talk to your teacher, and they'll explain what's happening. So that is going to be choice 3. Okay. All right. So this is the cross section, rotate a 2D shape, to form a 3D solid. So if we rotate 360 degrees around W, what you have to try to imagine, okay, is we're going to get, this point here is going to follow this path, sort of. Pretend that's 3D, Same thing here. Pretend it's 3D. I'm going to try my best here to, it's not great. So trying to imagine that, okay, so that's what we call that, is spatial reasoning. When we try to imagine what's going to happen, not easy to do. Okay, so if you can imagine that that's what we're going to get when we spin it 360 degrees, you're going to get a circle on top from this point, okay, and it's going to carve out a cylinder. So that's what we want to choose, and I'll stop this video here, and we'll pick up the other problems on the next one.